Hi, I'm Jeremy Rodrigues. I'm an Associate Professor at Warwick Clinical Trials Unit and a Consultant Plastic Surgeon at Stoke Mandeville Hospital in Buckinghamshire. I'm also a Director of Methodology Oxford Limited. And I've been interested in outcome measurement in Dupuytren's disease for over a decade now, and most of that now focuses on patient-reported outcome measures, PROMs, which are questionnaires we can use to capture outcomes from the patient perspective. 10 years ago, if I was giving this talk, I'd normally start by trying to convince you of the need to capture PROMs. But I'm sure most of you are aware that PROMs are very widespread, and this was summarised in a recent review that a team that I was part of undertook. And we can see that the orange line here, site-specific patient-reported outcome measures, hand or upper limb specific ones, really have grown in their use in the scientific literature in recent years. And, this generally makes sense. Traditionally, we've measured finger joint angles. We looked to see if the finger joints were straightened by the treatment for Dupuytren's disease, like this person who had a fasciectomy to her ring finger several years ago. Her MCPJ is 0 degrees, it's straight. The PIPJ is also 0 degrees, it's straight. And in studies such as the randomized controlled trial of collagenase, this was treatment success, and this was also adopted in randomized controlled trials of needle aponeurotomy and fasciectomy. And that can be perfectly reasonable for just showing that the treatment has worked at all. But if you ask her to make a fist, she now can't do that as a consequence of the operation, and she says that the hands actually become useless. A DASH score, which is between 0 and 100, 0 for no functional problem, and 100 for maximal functional impairment, is 49. And the developers say that if it's above 40, you possibly can't work. So we know that the hand is more complicated than just how straight the fingers are in Dupuytren's disease. And we can see that extension deficit on the x-axis here doesn't really correlate well with our functional scores, things like the DASH. The correlation coefficient is quite poor. If anything, in the last few years, what we've seen is a shift in the other direction, with PROMs being the solution to everything. And now the question really is, are PROMs a panacea? Well, let's work through this. And we can start with the WHO International Classification of Function. So this structures things effectively into 3 tiers: body, function, and structure. So you can get very biological about this, about how straight the finger is, how much Dupuytren's disease is present. Activity issues, so this is your functional impairment, inability to straighten the finger, inability to grip, specific activities like that. And they then have a knock-on impact on your participation, your ability to perform sports, to go to work and do your job, to dress yourself and engage in society in different ways. And as we move through these, just putting aside Dupuytren's disease, in general, they get more complicated. So straightening somebody's finger doesn't necessarily mean that they can specifically wash their face, and that does not specifically mean that they will reliably be able to look after themselves in independent living, for example. There's other noise that affects these activities, and that we could just call simply life. And really what we're talking about here is, if we're doing early phase studies, we're trying to just see whether a brand new therapeutic works at all, then we probably need to be focusing more at measurements of body function and structure. Finger joint angles are perfectly reasonable for things like that. It's just when we get to the latter stages of, does this actually change how somebody can do tasks, and does this actually change then how they participate in society and the health economic impact from that in our societies and our economies. In those later phase studies, that's where we need something that has more sophisticated measurement and an ability to record how people are actually behaving. PROMs themselves are not the actual outcomes in these situations. It might be hand function or it might be quality of life, but PROMs are tools for measuring these. And I think it's important to decide which outcome is to be measured and to relate that to where the study is being performed, whether this is a very early phase study, whether this is a later phase real world effectiveness study. And then once we determine what we're measuring, hand function, finger straightness, then choose the tool to measure it. And that tool could be a goniometer or it could be a PROM. Early phase scientific work is probably slightly different from some of the things that we're talking about. And I think finger joint measurements and things like this are perfectly reasonable. But in the function and participation type studies, the later phase studies, PROMs probably are very important. It just goes to show that they're probably not a panacea for everything though, and we need to just bear that in mind. There will be situations in which a PROM is not necessarily what we need. So what then actually makes a good PROM? And we can look at PROM behavior in different ways. And in particular, what I want to talk about today is validity of the PROMs that we have for Dupuytren's disease. This is whether they're on target, as opposed to whether they're consistently on target with reliability, and whether they change with time and are easy to make sense of with responsiveness and interpretability. We often hear people talk about valid or not valid outcome measures, but validity is actually quite complicated. It's not as simple as yes or no, valid or not valid. We can look at criterion validity. This is not often appropriate. We can look at the content of the items, whether they're comprehensive and relevant, and we can perform some kinds of statistical analyses to look at the constructs. The construct here being the underlying latent entity. So hand function is a latent construct. It's not something that we can see like height or weight or shoe size. It's something that does exist, exists in people's minds, and we need to find ways to measure that in a quantitative way that's robust. And we can test this. And that's starting to get a bit heavy, so who actually cares? Well, I think that we can split this into 3 levels, okay? The first is making sure that we measure the right things. The next is making sure that we measure them accurately. And then, ideally, we measure them efficiently. We don't pose people questionnaires consisting of hundreds and hundreds and hundreds of items. So let's walk through Dupuytren's PROMs in these 3 steps. Measuring the right things. So we're fortunate that actually there's been a recent ICHOM exercise to generate an outcome set for adult hand surgery. And this provides information about what constructs need to be measured. These include things like hand function, quality of life, pain, and satisfaction with treatment. Some recommendations are actually made about which outcome measures are suitable, including some PROMs. But bearing in mind that PROMs are ultimately tools to measure the underlying construct, and the construct being hand function, let's look at what hand function type PROMs are available in general. This is another piece of work that a team that I've been involved with have undertaken, led by Justin Wormold and Luke Gagan. And they work through all of the different types of validity for a range of commonly used hand and upper limb PROMs. And in particular, we said that the structural validity, which is how the different items in the PROMs relate to each other, is an area that we think is quite important. And you'll notice on the left-hand column here that of the PROMs that are available and widely used, this hasn't been well studied. There's a lot of grey boxes there, which means that we just simply have no idea. And this includes some of the PROMs in the ICHOM set, things like the Michigan Hand Outcome Questionnaire. Others, like the DASH, have been subjected to some analysis and have not necessarily fared in the way that we would expect. And we can talk a bit about this. So we mentioned structural validity, and what does that actually mean or involve? Well, as we said, hand function is a latent construct, and we'll call that factor here. It's in a circle. It's not something that you can see directly, but you can ask some questions in a PROM, which are in square boxes, as these are tangible exogenous things, questions that people will write an answer to, and they should reflect something about the hand function. If you're going to add all Q1 to Q5 up to make a single score, it would make sense that they would all be about hand function and not about other things. However, that's an assumption, and it's quite possible that some of these questions do relate very cleanly to hand function and others relate to something else. And some of the earlier work that I was involved with looked at this for the DASH, which had 30 items, and we found that actually they didn't all load on a single underlying entity. They weren't all adding up for a single measurement of hand function. Instead, what we found is that the task items, the top ones, congregated together and loaded on one underlying factor, and the symptom items loaded on something else. And I suspect that in Dupuytren's disease, this may be because the task items here, which remember are for the arm, shoulder and hand, act across the entire upper limb function. So change a light bulb overhead, do heavy yard work. These are tasks that may or may not be affected by the Dupuytren's disease in your little finger, but the symptoms down at the bottom may well be. And at the point we raised this as a question about adding up all 30 items to a single score in Dupuytren's disease. But what it illustrates is that we need to make sure that the concepts that we're measuring are correct. We need to see that the items in the PROMs that we're using actually measure the same construct, and we need to then make sure that the constructs we're measuring actually matter. So perhaps upper limb function overall is not what we necessarily need to measure in Dupuytren's disease. Perhaps symptoms are more relevant, and we can take this forward, and I'll come back to this with some more recent work we've done on this. But this is just an illustrative example of some of the kind of research that we can do. What about measuring things accurately? Well, let's put Dupuytren's disease aside. Let's say we are interested in jogging because we're trying to get fitter. We develop a PROM about somebody's ability to jog, and it consists of 2 questions. Can you walk 5 steps? Yes or no? If you put yes, you get 1. If you say no, you get 0. Can you run a marathon? If you say yes, you get 1. If you say no, you get 0. And that's the entire PROM. And it's supposed to tell us how good people are at jogging. Obviously, somebody who gets 0 can't jog and is at a very low level of jogging ability. Somebody who can run a marathon and take 5 steps scores 2 out of 2, and they're an expert jogger with no concerns about their jogging ability. But what if you score 1 out of 2? You can either run a marathon but for some reason haven't managed to walk 5 steps, or you can walk 5 steps but can't run a marathon, and we won't actually be able to separate those people. It's a slightly extreme example. Well, what if we analysed this same questionnaire with those same response options in a slightly different way? We probably can agree that jogging ability will exist along a scale, which we put on the x-axis along here. People can say yes or no and score 0 or 1 point. So the first question was, can you walk 5 steps? At very low levels of ability, all 4 people here say no. At some point, some of the people start to say yes, they can. And then above a certain level, everybody can walk 5 steps. If we then change this to the probability across a population, we end up with a curve that looks something like this. If we then also ask about marathon running, we will get a curve positioned somewhere else along jogging ability. And if we had several other items in between, we'd be able to anchor these 2 curves alongside other curves to see exactly how far apart they are and get true continuous measurement of jogging ability. It's effectively like dropping questions onto a thermometer. Is the water boiling? Does the water have ice in it? We can understand roughly where on a thermometer those questions are, and they're not all equally weighted. And we can do this kind of work with our existing PROMs. So here we've taken some of the function items out of the dash, in particular the 6 function ones that are in the QuickDASH, and we looked at some people's responses to them. And what you can see in the top left are response sets here, and what we see is the curve for response option 1, which is no problem, up to mild, moderate, severe, and the orange curve being cannot do. And you can see that initially there are some issues with some of these curves. In dash item 6, people aren't really separating options 4 and 5 from each other. So we can rescore the existing answers to correct this issue, and then we get nice even measurement in which one option after another becomes the dominant response. And this was done by collapsing 4 and 5 together. So there's now only 4 response options, but each of them in turn becomes the predominant response. Done that, we can pick the thresholds, the points where those change, where people become more likely to give response option 2 than response option 1, response option 3 than response option 2, and so forth. And if we look across all of the questionnaires, or all the questions in the questionnaire, we can identify all of their thresholds, and then what we can do is, and that's what we've done here in some work conducted by Conrad Harrison with a data set kindly shared from the Fife Virtual Hand Clinic run by Jane McKeekin in conjunction with Paul Sterling. And what we can see in this particular data set is that for people with carpal tunnel syndrome, these function items sit very closely to the location of the people, which is shown by the curve on the left. But in Dupuytren's disease, most of the people are sitting in a level below the severity of these upper limb function problems. The questions actually work well, it's just that they're not necessarily well targeted for this particular population of people with Dupuytren's disease. And of note, these are the function items. The symptom items do behave better. So this helps us understand whether a PROM such as the dash is suitable. It helps us refine measurement as we can adjust scoring accordingly. It ensures that we have appropriately granular measurement. We're now working on truly continuous scales rather than on ordinal sums. And what we saw from this particular work is that dash symptom items tend to function better behave better than function items for people with Dupuytren's disease, and that wouldn't necessarily be the case in carpal tunnel syndrome as we saw in that particular data set. So building on what we did previously, rather than simply say, well, the DASH doesn't make a single score, it measures function and symptoms separately, rather than stop at that point and say, well, let's not use it, what we've said here is, okay, well, let's separate those out, and perhaps based on these data, the function items might be slightly less suitable than the symptom items, and we can move forward with that, either using the same items, or if we're going to develop new problems in the future, we at least understand where our challenges lie and what problems we've had. So finally then, what about measuring efficiently? Well, this can be like the children's game Guess Who, which certainly is very popular in the UK. You have to guess your opponent's character. Here you have 8 characters. You could go along and ask 8 questions. Is it Bob? Is it Dave? Is it Julie? Is it Sue? But you would ask 8 questions and you would lose the game because you were not being efficient. What if you ask questions in a more rational fashion? Is it a woman? And if the answer is no, you could eliminate 4 in one go. You could then ask, does the person have dark hair or not? And you can narrow down without asking all the questions. Because we can place items along a continuous scale, a thermometer with item response theory, we can do the same here in what's called a computerized adaptive test. We have our thermometer. We can ask a question somewhere in the middle. Is the water hot? If the answer is yes, we don't need to ask whether there is ice in the water. That does not add any further information. Instead, we can focus our questions on the top end. Is the water too hot to touch? Is the water boiling? And we can narrow down our answer again without using all of the questions in our scale. We were interested in doing this with the DASH, which has 30 items, and as we've said, it focuses across the arm, shoulder, and hand. There is a shortened version of the DASH already called the QuickDASH, and this was developed with the concept retention method to try and retain the underlying entities being measured, with the aim of generating something that was shorter and quicker and is 11 items long. But this development doesn't account for the pattern that we saw, where the function items are behaving separately from the symptom items. As we said, the very initial idea was to say, well, perhaps we shouldn't be using these questionnaires, but can modern psychometrics actually help? We have quite a consistent pattern in 2 data sets showing that the function items behave differently from the symptom or perception items. Can we harness this? And in particular, we're interested in this because symptoms and function are related. They actually correlate in our data sets. What this means is that information about one provides some illumination about the other. If you know that somebody has pain in their hand from a pain question, that does tell you about their symptoms, but it spills over into telling you something about their function as well. It's a bit like completing a crossword. Here we've completed the word hand at the top, and in doing so, we've got the letter N to begin needle for our needle aponeurotomy running down. The N shares information across both words. We've been interested in this work, and Conrad's developed a multidimensional analysis to try and reduce burden and see how this compares to the QuickDASH. So we developed a multidimensional computerized adaptive test in which we looked to see whether there is information about what's been labelled as θ1, which would be the function score here, with function-based items, but which share something with θ2, which is the symptom score running along here. So there's 2 separate scores still being generated out of the same DASH items, but each question can potentially share information across both scales. We tested this with simulated patients, and we found that when we applied MCAT, we only needed between 8 and 9 items on average to get a score for both a function score and a symptom score. And in some cases where people were located at a high level of information, so close to the peak of this graph, they only needed to answer 3 items to generate both scores. This is obviously in contrast to the fixed short form QuickDASH, which is always 11 items long. So what this shows is that we can then apply contemporary psychometrics to existing PROMs, and sometimes previously perceived limitations like multidimensionality, the fact that there's a separate function and symptom score, can actually be overcome and even harnessed to get more efficient measurement. We can use existing PROMs and data sets so people who've completed responses can have these new scoring systems applied to them. and we can also inform future PROM design, as we've discussed already. So in summary, measurement in Dupuytren's disease certainly has evolved in the decade that I've been working on it. Core outcome sets and outcome sets like the ITROM set definitely help us to standardize and target what we're doing, but this is a dynamic area in which there's continuous progress, and I think that we'll see new and exciting movements in outcome measurement in Dupuytren's disease in the coming years. Stripping back to being pragmatic, at the end of the day, measurement does need to be fit for the purpose intended, be that an early phase scientific exploration or a registry or a health economic study, and it's really critical that we measure what matters accurately and try to do so with low burden to achieve high completion rates by our participants. Thanks very much.